Oh, there we go. All right, we are ready. We're gonna do a little bit of Fusion 360, SolidWorks. Well, not SolidWorks. We're gonna do actual Fusion, so CAD modeling. That's what I meant to say. We've got to finish up our fasteners, so we'll look at those. I actually had to do a reprint, so we'll look at why and what I did, and that's probably enough for today, I would think. Let's look at our schedule. So we are here on class 27, so we're getting close to the end. In fact, I think this Wednesday, like next class, I don't think we'll meet then, so no stream on Wednesday, I believe. And what we've got left is today, so the fasteners, that sort of stuff. You do have to start turning all of your stuff in. I know some people have turned in several assignments. I looked at some of them. And just make sure that you get everything in by the last day of the class, which is next Thursday, not this week, but the following Thursday. I think that's meant to be the 15th. I actually don't know the date on that, but something like that. Let's see, today's the 5th, so yeah, I think that's the 15th, August 15th. So make sure you get everything in by then. If you're going to do the class contest, I've got that on class 29 as far as where you can upload things. I don't know if anyone has yet or not. Let's see, you would actually upload them here. Oh, there's one. All right, we'll look at that some other time. So we'll see how that goes. You don't have to do the class contest. You can do one of the others. I saw somebody in the Discord posted a class, or well, not a class, but a contest, a 3D printing design oriented contest. So you could enter that. You don't have to win or anything to get credit for it. You just have to show that you entered it. We've got, if we were in person, what Wednesday would be a kind of troubleshooting, over here. I noticed that quiz 3 and quiz 2 are out of order, so that doesn't matter. Quiz 3 is just a survey on what would you like if you were to take the course again. Probably you're not, but if you were, what kind of content would you like to see? So that's what quiz 3 is. But what we would do is have a troubleshooting day. So since we're not in person, then troubleshooting is a little bit more difficult. But if you need some troubleshooting, that's kind of what we've got on there. So no stream on Wednesday. And then this would be Friday, turning in the class contest just to give enough time to grade the things. And then we've got quiz 2. It'll open up next week, and basically that's what you'll have for next week. And if there are any last minute things to talk about, then we'll talk about other things. Today what we're going to do is, I thought we would go over to Fusion, just because it does have a free version that you can use, an educational version. I think SolidWorks has something similar now. Obviously you have your license of SolidWorks from school, but it will eventually run out. And I guess Fusion, I don't remember what their current free version, non-educational, is like, but I just thought I would do this one in Fusion. So we'll go there first, and then we will, while that part is printing, we will look at our fasteners. So that's my plan. So I'm going to go to Fusion. The idea here is that we're going to make a box. So I normally would tell you, do not make and 3D print boxes, because you can probably just buy a box, like a project box or something like that. You can probably just buy, better than actually going and purchasing or printing a box. But what we're going to do is mainly to give you some few other tools that you can work with. We are going to take our little, oh, we're upside down. Hold on, let's get right side up. We're going to take our little tin here. I've got a whole bunch of extra nozzles in there that they just kind of float around. So we're going to make a box for these nozzles, and it'll have a lid, and we'll just show how to do some of these things in Fusion. SolidWorks has similar, maybe they're named different, but tools that are similar, so you could do the same type of thing in SolidWorks. So our idea, or my idea anyway, is that I've got all of these that don't fit. So these fit, they're nice, and they're contained. This is a little foam insert, we're not going to do a foam insert. We're just going to have a 3D printed insert. Although I suppose we could 3D print in like TPU or something to make it compliant. Maybe we will do that. I have some TPU over here. Now that I look at it, it's still in the box. I haven't even opened it. So it's blue. I don't know if you can see. Let's get it out of the box. Where's the lid? So now that I think about it, let's use this. So it's some TPU, so it's flexible. It is blue, kind of transparent blue. So that'll be interesting. Let's try that for our print. I'm going to go ahead, since we're going to have to change filament on, we're going to print it on our little, now that's upside down, so I can't have everything right, I guess. We're going to print it on there, and it's currently got PLA in there. So let's go over to our dashboard and heat up to 200 just to be able to get the filament out, and we will switch over to this TPU. So that'll be fun. We have not printed a lot of TPU in class. We have printed some. So TPU is a much stringier material, and the printer this Voron has a direct drive. So direct drives in general are better at TPU because direct drives have really short retraction distances, and we may not even be able to do a lot of retraction with TPU. Plus they have a almost completely constrained feeding path, so the TPU doesn't have a way to, you know, jump out of the path or something like that, or bind up in the tube or something. So in general, direct drive printers are better for TPU than the Bowden tube printers. So wow, I don't know. Look at this. So all right, so let's look at this. I'm a little worried. So it says bubble free. Okay, fine. It says tangle free. All right, what you want tangled, untangled filament. But look at this. I don't know. This first layer is all wrapped around on itself. Maybe it's just sitting on top of itself, but it looks awfully tangly. Like that's, I guess that's how they secured the end, but it was underneath some of these other wraps, and they're all overlapping. Hopefully it really is tangle free. I don't know. This is from Giant Arm. I've never used any printed filament from Giant Arm, so we'll see how it goes. Let's see. We are heated up over here. So just so you can see changing filament on this guy, because I don't think I've done that. It has a little catch right here that clamps down on the filament. So I'm going to push them through and then pull it out. And that's all. Oh, it was almost broken in there. So it's brittle. I need a roller here, so what I'm using back, you can barely see the top of it here. What I'm using back there is one of the filament dryers from Sunlu, and I'm really just using it as a roller. TPU is one of the materials that can get a little moisture problems, but this has been vacuum sealed up, so I think it's okay. Okay, so let's route this thing out of here. And let's see if we can get it to feed in here. All right, so the general, I'm going to cut a little angle on here just to give it a little bit better chance of finding its home. And I'm going to clamp down. Usually we're okay. I'm going to heat it up a little bit more. Does it give me a printing temperature for this? Hog free. Doesn't tell me when. So I'm going to heat it up to about, let's do 210. Okay, and I've got it fed in here. I'm going to give it 50 millimeters of extrusion so that hopefully the pinch roll in here grabs it and sends it through. We'll find out. So let's see. It did grab it. Sort of. It tried to grab it. This is one of the issues with, look at that. That's one of the issues with TPU, is that it's really hard to get started sometimes because it's so flexible. And this is actually a pretty soft one. I'm hoping we can get it to feed. If not, we'll go back to our PLA. It's not super important. I just thought of it that I do have some of this sitting here. All right, let's try to feed it some more. Go, okay, we're going in. Are we coming out the nozzle though? Not yet. Oh, all right, so we are. Yep. All right, so that grabbed it. It's kind of floppy up there, but we'll deal with it. I don't have. We'll use these for my tweezers. So there we go. We purged some of the blue. It was green before. All right, so that'll be ready to go once we have something to print. So let's go back over to Fusion. Let's get it on our screen. All right, so my idea is to create a little box in Fusion that will hold some number. I have currently 1, 2, 3, 4, 5, 6. I have 7 of these, so maybe 8. Oh wait, is that another one? No. So maybe 8 of the, regular size little nozzles. So we'll get some dimensions off of those. I will say that the fastener thing that we designed last time, when I printed it, the internal holes, the outer dimensions were fine, but the hole sizes were too tight. So none of the fasteners actually fit into the holes. The hex nut didn't fit. The screws didn't fit. Nothing fit. So I did fix that without redesigning it. So I'll show you how to do that also if you ever get into that situation. But this one I might design the holes a little bit larger because these aren't actually supposed to be fastened anywhere. They're just supposed to be there. Now the good thing is we're printing in TPU, so that means that it should be a little more compliant, and the holes will form whatever size they need to form. So got my caliper over here. So first let's get the basic part of the box, and then we'll do the insert part of it, which isn't going to be an insert, it's going to be part of it. All right, so we're going to create a rectangle. I think this should be a rectangular box, 2-point rectangle, something like that. D is dimension, and we're just going to pick. Let's lay these out over here. Kind of what I think they will look like, and get some dimensions off of that. I need to have them far enough apart that I could reach in there and grab them without, tweezers or something. So I think if I want 8 in there, I'm over here, so you can't actually see what I'm doing. I'm over here laying them out. So I want them kind of far enough apart that I can easily grab them. So something like that, and then there'll be an 8th one over there. So that would give us, this dimension needs to be somewhere around, let's say 45, and this dimension somewhere around 70. 45 by 70. Let's do that. Now, one thing to consider, sort of anyway, when you're designing for something that's going to be FDM printed, is that you have a layer height and you have a line width. And if you can make your parts in increments of those layer height and line width, your slicer won't have to try and do half lines or leave some gaps or anything like that, or it won't have to try and slice it in some uneven number of layers where it has to decide, do I give it an extra layer or do I print it a layer short? So if you create your designs to begin with the idea that I'm going to print this with a 0.3 millimeter layer height because that's the maximum I can print on this particular nozzle, and I want it to be a line width of 0.4 because I've got a 0.4 millimeter nozzle. If you think of that up front, that'll save a couple of little potential inaccuracies when you're printing based on how your slicer has to slice the geometry you made. So right now 45 and 70, that's probably not a big deal to worry about. Any of your nozzles are going to be able to divide those, because you're not printing this solid. It's going to be some number of walls, probably 2 walls for us, and we can easily squeeze in 2 walls in this dimension. All right, so let's finish that. I do think I want to print it at a 0.3 layer height just to kind of speed up the printing process. Normally you have to print TPU pretty slow anyway, because it just doesn't flow the same as PLA, so I have to print it a little bit slower. So I do have to be conscious of, I don't want this to take forever. I'd like to finish it during the stream if possible. So my height here, let's do, if I do 0.3 and I want it to be what, 21 millimeters tall, that would give me 70 layers, except that it's going to be a top and bottom, so they'll be separate. So actually I guess I need something that each separate piece can be divisible by 3 or 0.3, which I guess is the same. Let's see, so how about we do 15 and 6, which would be 21. All right, so let's do that. So let's make this the whole, so I'm clicking it E for extrude, 21 millimeters up. There's our basic box. Let's make it a little bit more fancy than this. Let's see, make sure that we actually, you know, these things will fit inside there. So they are only, oh, dropped it. They're like 13 millimeters tall, so they'll fit inside a 21 millimeter box completely fine. Let's round off the corners, so I'm just going to select each of the corners here and hit F for fillet. Let's make it a, I don't know, 5 millimeter fillet. Okay, sure. We could round these top corners. You know, we could like round this, select this whole surface and round it like that if we wanted to. We just have to be aware that I'm going to print this like open, where the top surface and the bottom surface, the top of the lid and the bottom of the box part are on the bed. So I don't want too many overhangs that are going to be droopy, because I don't want to use supports in here. So I think we'll be okay. Let's do a 5 millimeter just to have it some kind of feature there, and I think that'll be okay. It might be slightly messed up right on that edge where it starts to roll over, but we'll see. All right, so there's our little box so far. Now we need to make it into a box. So if you were creating like a wooden box, one way, and maybe a, I don't know, best way to make a box, you know, you could imagine you get all your sides and build them together, and then build the top, and you know, they match up. But what people often do is they build basically what we've built here, and then they take it to bandsaw or a table saw or some way that they can cut the whole thing in half to separate the top from the bottom. And so that's what we're going to do here. We're going to make a plane that, let's see, I said it needed to be 5 millimeters down. Did I say that? I did say that, except that now that I think about it, we made that chamfer, or that fillet, 5 millimeters. That would end right at the where the fillet ended up at. So actually this needs to be 6. I want it to be divisible by 3, so -6. There we go. That gives us 1 more millimeter. So there's a plane, and then I can use modify over here to, I can where's it at, split body. So I can select over here, is it all, yeah, it's on your screen. So I can, the body to split is the box, the splitting tool is that plane we just made, and now I've got 2 separate pieces, although when I select them they're all the same. So I'm going to go over here to the construction. So I'm on the left hand side over here, and not there, I meant in bodies, I meant. So I've got body 1 and body 2. So I could deal with them this way. I'm actually going to right click. First I'm going to rename them. This is the bottom, and then we'll rename this one to the top just to keep track of them. But then I'm going to right click and create components so that I can activate and inactivate them as I need to. So create components, and create component here. So now I've got 2 separate components that I can work with. Now it might be, if you do this, and let's say you activate one of them. So I've activated the bottom, so it's currently the one that I am working on, and I could hide the top one if I wanted to. It might be when you do that that the one that's not active is kind of transparent looking, and that's annoying to use. I think that's the default setup. I have mine turned not that way, and I control their visibility over here. But if you don't like that, and yours, like one of your components that's any of your components that aren't active, if they're kind of translucent and that's bothering you, then it's behind my let me move over here. So over here you have this little tab, and it's got, your avatar preferences, and in here it'll bring up this window. I believe, I think it's in design, and it might be in configuration. No, assemblies. Yes, it's in assemblies. So design assemblies, because now basically I have an assembly of 2 components. This active component visibility, if you click that and apply it, this is the default. So this is what happens, and I don't like this personally, but whichever one is active is solid, and the other components are kind of a wireframe translucent thing. I want to be able to control it myself with the visibility icons over here. So what I did was I went over here, preferences, design assemblies, and I unchecked active component visibility and applied that. So what that does is it makes all your components visible, and then you can hide them as you want to. Now it completely hides them. It doesn't give you the little translucent outline, but that's the way I prefer it to be. All right, you get to choose how you prefer it to be. All right, so here now we have a box-ish looking thing. It has a top and a bottom, but it's not hollow. Like, it's solid slabs of, in this case, what will be TPU. So we need to hollow it out. So let's hide the bottom. Let's hollow the top first. So over here in our modify, there is a shell command, which basically you pick a surface that you want to be opened. So I want this to be opened, and then you decide how thick do you want this to be, like the walls to be. So I think, again, I'm printing at 0.4 millimeter line widths. So I think if this is 2 millimeters thick, then that will work. So there's kind of our shelled lid. Okay, now we can hide that one and do the same thing for here. So I will modify shell. It's actually this big button right here. I could just click that button, but shell, we'll click the top surface here, and we'll shell that one also 2 millimeters thick. And then there's the bottom. You do have this shell type over here, these 2 options where you have sharp corners and rounded corners. The rounded corners, in this case, I don't know that they do a lot different. Let's see if they do any difference. Yeah, it doesn't make any difference on this particular design. So might as well do sharp corners. All right, so we've got now a lid, a bottom and a lid, and they perfectly fit together. It'd be nice if there were some sort of features. Now, I don't know how this is going to work in TPU, because TPU is pretty flexible anyway. But in a more rigid material, you would think you would have some kind of lip and groove that would kind of fit together. So here's one way we can do that. Now, I will say, if you have one of the versions of Fusion that has the plastic add-in here, and you have access to I think this, yeah, this right here, this lip, it will create lips and grooves for you. We're going to manually model ours, but there are some snap fits, some bosses. So there's some tools here that will create some of these features with all the draft angles and everything that would be necessary if you were injection molding the part. So we're not going to do that though. That's not available to everybody. Even I think if you have an education license, you can check out that for 30 days for free, and I think you can re-up it every 30 days. So I think you can keep checking it out if you want to. Let's hide the top and work on this one. So I'm going to create a sketch on that top surface, and I'm just going to do an offset from, let's say, in here, and let's offset, that'll be -1 millimeter. So my idea here is I'm going to create a little ring around it that I can extrude up to create the lip or groove, whichever this one is, I don't know. But I probably need a little bit of gap. So I'm going to make this 0. Let's do, now here's a instance where I probably should be thinking of my line width increments, right? So I'm doing a line width of 0.4 millimeters. So I plan to print this with 2 walls, so that would be 0.8. So why don't we do 0.8 here? Okay. And then what we can do is we can select that newly, we have to finish the sketch. And then we can select, if I zoom in, that newly produced ring, E to extrude it, and then we can extrude it maybe 2 millimeters. I'm not sure how well the TPU is going to create this feature, but we'll see how it works. Oh, you know what? We might have a problem. We'll deal with it if we have a problem. We can fix it. But let's carry on, and we'll see if we have a problem or not. So now let's check out what we've got here. Here's our top back visible. Let's look at a cross section. Where's that at? Section analysis. I guess we're still in the, there we go. Okay, I think it'll be okay. So there is a little bit of weirdness here where our groove is cutting out a bit of the, it's leaving a little bit here of the lid. So, because it's so tall, if it was shorter, it wouldn't do that. I don't want it to be much shorter though, because I want to have enough of it to grab on there. So I think we'll just deal with this little piece separately. We'll deal with that separately. I think that's what we'll do. All right. So what we could do is we could combine. I'm debating on if I want to do this or not. We could combine these two pieces, and normally you think of combine as joining, but in Fusion, combine can also mean like it's a Boolean operation. So it could be cutaway. So we could combine the top and bottom as a cutaway tool, and it would cut a matching groove in the top. But it's going to leave that. Okay, let's close the section here. I don't know what it's doing. There we go. I think that's what we'll do. No. So let's do that so you can see what happens. So let's do modify, combine. Over here, our target body would be the lid. The tool body would be the bottom. And instead of joining, we would cut, and we would keep the tools. We don't want to, remove them. And what that does is now the way we created that, if we change anything about the cutting tool, it automatically changes the cut tool, so the target. So we don't have to go and edit both sides of the top and the bottom in order to change the lip and groove that we've created. We just edit one of them and it automatically updates the other one because it's a function of it, versus they're two independent operations of, you know, cuts or extrudes or whatever. So let's look at our cross section again, and it looks almost great, but when you zoom in, you know, I've got this weird thing going on. So I think what we'll do is we'll remove that manually. I think that's what we'll do. Now, one thing that this doesn't do is it doesn't give us any clearance, right? These are perfectly matched up like they would be in, you know, theoretical Fusion world. But when I go print them, one might be a little bit smaller or larger than the other and they don't fit too well. So I have no tolerance in here the way I've made it here. So I think what I'm going to do is, instead of doing our combine, I am going to, all right, so let's cancel our section analysis. So instead of doing our combine, I think I'm going to actually just create the lip on the top one like we did on the bottom one. So let's undo our combine, which I actually, oh, can I not undo it? Huh. Let's see. All right, so I did undo it there. I hit Control Z. So there we go. All right. It wasn't in my timeline down there. All right, so let's hide the bottom. Look at the top, and let's basically do the same thing we did before, where we create a sketch on this surface. Oh, except that's the bottom. Why are we looking at that? I want to look at the top. There we go. I guess it re-showed it to me. And let's offset. Oh, all right. So I've got the other thing here where I think what happened. Let's cancel. I think what happened is it created the sketch on the bottom piece because, look, I've got bottom set to the active part. I need the top to be the active part. So since I have components here, I said part, so these are components. That's why it didn't want me to mess with the top, because I didn't have it active. All right, so I made it 0.8 millimeters of extrusion, so I need to do 0.8 and a little bit more, but not a whole line width more. I'm going to do 0.85, but it's going to be negative because I want it to go the other way. There we go. And that'll give me a little bit of tolerance in there. And now we can finish the sketch, and we can grab this guy, extrude. We're going to extrude this one down, and I made it 2 millimeters, I believe. So let's make that -2 also. Hopefully it doesn't go through it. I don't think it does. There we go. And so there's our little feature. We've got some weirdness, you know. Oh, whoa. We have a lot of weirdness. That's actually really strange. I think it's just an optical illusion, but it looks really strange to me. I'm not sure. Actually, I don't know. It looks... Oh, it's doing the same thing. Okay, it's doing that same little issue where we have that thin piece. So let's create a sketch on here. So this is the bottom of the cut surface, and let's just create a offset from here, and we'll just offset it a little bit inward. That's fine. And then we will select that surface and that surface, and we will extrude these upwards, and I think that'll get rid of those. Okay. I think that'll get rid of it. All right, so there's removing that weird little thin piece. Same problem we had with the combine function. So the downside of doing it this way is that these two, this groove and the matching one on here, are not dynamically linked together. They just, I designed them that hopefully they work together, but they're not at all dynamically connected. With the combine function, they were, when I changed the bottom, it automatically changed the lid matching piece. The upside is that I added some tolerance in there, and I got rid of that little thin strip that was going to be in there. So I think this is better in this case. In the plastic, you know, in the not snap fit, in the lip function over here, all of that stuff happens automatically. Now there is one thing here. You see this little, I can't, all right, so just in the preview, the right hand part of the preview, it has this reveal. So that's the little blue line here, kind of on the outside. And it's a design feature, which one, it gives you a little bit that you can grip a hold of to remove the top from the bottom. Plus it indicates that, hey, these are separate pieces. It gives a clue to the function of how this box is supposed to operate, that, oh, there's where the top is, because I can see the reveal or the edge of it. And so it's more of a design feature than a functional feature, but it does have some function on actually letting you grip the top. So let's add that. And to do that, all we need to do is cut away a tiny little strip on either the top or bottom. Since the top is already pretty thin, let's work on the bottom. And let's just cut a super thin little reveal in here. So that would be create a sketch on here and an offset line from I'm on the bottom, there we go, offset line from there. Oh well, offset line from, I want it, select that. So let's see, cancel that. Let's project that ring. So for some reason it wasn't letting me select it as a tool to use. So here we'll just do it this way. I'm going to make this one line width, so 0.4 millimeters, negative 0.4 millimeters to make it go inwards. And then I'm going to make it one layer height. So I'm doing 0.3. So we will select that surface, extrude it down negative 0.3. And, oh wait, negative for that one is the other way. So positive 0.3. There we go. All right, and now when I put them back together, I've got that little reveal in there. Okay, so that's all we need to do. Well, so the other part that we didn't do is we didn't put any holes in here. Let's hide that construction plane, it's annoying. We didn't put any holes in here to actually hold our nozzles. So why don't we, that thing, I don't want that surface in there. I think that's, I don't know why I can't delete it. It's from when I cut the inside part out, I think. So we could either create an insert separate, or we could just build in the bottom down here, extrude it so that there are holes in there. This plane is creating problems though. I don't know why it is visible, but I guess, I wonder if I can just put some holes on it. I don't actually know the correct dimensions. These things are like 6 millimeters. And then we can space them apart. Looks like I had them spaced maybe 20 millimeters apart. No, too far. 15. I guess I can do the math to figure out that that's not going to work, is it? All right. There. We could either go in and align the, oh wait, I made that 10. Align them, or we could just type in our dimensions. I think we're just going to type in our dimensions. In this case, it's faster for me. And then let's, those can be a little more. All right, now we need these to all be equal, so that if we ever want to change them all, we can change one dimension and it changes all their diameters. So now I think I can extrude that down and we'll have our holes in there. And we'll, I don't remember what distance, we'll just extrude it down to the, well, no, we don't want to cut away. We will join. There we go. So I just changed it from cutting over on the right hand side to joining. And there's our little base. It's got a lid. I might have, you know what, I might have this surface too high, because I do need the nozzles to sit up and not poke in the lid. So the nozzle is going to sit up about 10 millimeters, and I only made the lid, I don't remember. So let's drop this thing down 5 millimeters. There we go. I'm not calculating, we're just guessing. So I think that'll work, maybe. All right. So there's our top and bottom. So we double click on it to select it all, or we select it in the browser. Right click on it, save as mesh, and 3MF is fine. This will be bottom nozzle box. And then we'll hide that one and get our other one. Select it all, right click, save as mesh, top nozzle box. Okay, that should do Fusion. Now let's go to, we were using Orca Slicer the last time, so let's use that one. So there's our two pieces. All right, so here, we'll get to this in a minute. I'm going to discard that for now. Let's get this part laying on that bottom and the lid laying on that bottom. We can auto arrange so that they will fit. Looks like they will fit on our little Voron print bed. We have to change our material. Generic TPU. Let's check our settings on there. It looks like it's going to print 200. Well, that's the minimum maximum. It's going to print the nozzle first layer at 240 and other layers at 240. That seems kind of hot. The printer can do that. It just seems kind of hot. I'm gonna drop that. I'll leave the first layer. Normally you print the first layer hotter to get it to stick down really well. But I'm gonna leave that one at 240. But I'm gonna drop these others to 220. And if it doesn't look like it's printing well, then we can change it in the dashboard. It looks like we've got our bed pretty cold. I think that's okay. One thing with TPU is that it can really stick to smooth surfaces. So like glass or the smooth PEI, it can stick to it so well that it rips it apart. So I do have a textured PEI sheet on here, but I think I will put down some glue stick just to act as a separate, or maybe I'll do hairspray because the glue stick is kind of gummy, and the top of our lid is going to be on the bed surface, so it's going to be a visible part. So I don't want it to be kind of yucky with glue stick texture. So I think I'll use hairspray if I can find some. TPU doesn't stick as bad to the textured PEI sheets, but if it was the smooth, it would stick pretty badly. So let's say that's okay. That seems okay. We are at our 0.3 layer height and our 0.4 wall line width. We are doing 2 walls. We don't need supports on this, so that's off. Speed needs to be slower, so yeah, it is slower here because of TPU. So let's slice that. Let me see if I can find my hairspray for this release agent. So I'm going to use this. Okay, just sprayed it on there. In case you didn't see, that's what I normally use for if I want something between the surface of the bed and whatever I'm printing. So TPU, some materials that don't stick too well, sometimes that cheap, really thick Aquanet will help them hold them down, and it will work as a release agent if you need it to release. All right, so we've looked like we've got a decent looking print here. Everything looks okay. Let's print, upload and print. So we'll check back in on that once it's done something. And oh wait, what was the print time? Oh, so we won't finish it in class. So it's an 1 hour and 37 minute print time. So we won't finish that during the stream. If we were printing in PLA, I could print a lot faster and it'd have a much better chance of printing. Also, if we didn't do the insert and we just did the box, that would be pretty fast. But the insert, there's a lot of infill going on in there, so I can see why it takes that long. All right, so back to our fasteners. So last time we designed, and I think we printed it, but it didn't finish in class, this guy. Now that's upside down. All right, this guy, and every one of the fasteners, you know, they would not, you know, you probably could maybe get a hammer and force them to fit in. Same thing when I tried. This was our threaded region, so I don't know if you'll be able to see in there or not, but there are threads. Yeah, you can see them. There are threads down inside of there printed. This just, I was able to force it a little bit, but you can see how it was ripping everything out. This was our heat set. There was no way without just melting everything that our heat set insert, which I have currently lost, here it is, was going to go down in that hole. This was the threaded, either one of these, and it did attempt to go in, but it was, you know, pulling the top layers off of the block. And then here was our slide-in nut, and it was too thin and too narrow. So none of them worked. So I reprinted it. I did not go back and model things. You can still see that this one is still not, you know, still a little bit too weak over here. Some of that is the printing, and some of it's the sizing. So, but all of these now, you know, this goes in fine. Where's the screw for that? Here it is. This screws in fine once I get it started. That screws in fine. This one still has some issues because this one has some issues because we did a lot of time saving on our printing. This whole thing printed pretty fast, and we didn't have a lot of top layers or walls, and so it basically just ripped the top. You can even see it bulging out there. It ripped the top layers off of the infill, basically. Our little TPU guys started looking okay over there. We'll check in on it in a minute. Well, we haven't done our heat set. It looked like it was going to work. I just haven't actually done it yet. So we'll do that one here in a second. But let me show you if you end up with something like that. So the outer dimensions, like here and here, are pretty much exactly what we designed them to be. But all these inner holes were just too small. So most slicers have a way that you can enlarge or shrink the dimensions of your part. So in Cura, I think it's called some kind of compensation. Might be XY compensation. I don't remember exactly. In Orca, I think it's in, let me find where it's at. Is it in strength? I have to find it because I don't exactly know where it's at. Quality. Quality makes sense. Here it is. So these two options here, XY hole compensation and XY contour compensation. So they are named, oh, they're horizontal expansion. That's what they're called in Cura. I'm not sure what Prusa calls them, but it's probably similar to what Orca calls them. And so what the and there's another one, elephant foot compensation. So elephant foot, by the way, in case we haven't mentioned it, elephant foot would be, let's see if you can see it on here. Yeah, you can. Oh, that's actually a good example. So see how these layers right here, this is the bottom, right? This was on the print surface. So those first couple of layers are squished out. So remember, you normally print your first layer hotter, slower, so stuff is going to be a little more oozy. Plus, if you don't have your layer height, not your layer height, but your nozzle height correctly adjusted, then your nozzle might be a little too close to the bed because you're trying to get stuff to stick down. All of those are good things as far as sticking the part down, but they make this first couple of layers flare out, and they call that elephant's foot. So you can actually see on here, see all these little lines in here. All of those lines are also telling me that I've got too much material coming out of the nozzle on the first layer for how far the nozzle is away from the bed. It's trying to squish stuff on top of stuff, basically. So if you see those kind of features, this elephant's foot, those are basically saying there's too much flow for the amount of space to put the material. So either your flow rate's too high or your nozzle is too close to the bed. So, but maybe you need that to get the part to stick down. So elephant foot compensation will let you go in and say, hey, for those first, let's see if there's a number. Oh, it's just the first layer. So the first layer, I'm going to print it some number of millimeters smaller. I think you can do a percent in here also, but it says millimeters. So maybe it's millimeters on this one. Some number of millimeters smaller so that when it squishes out, it's lined back up with the print. So basically make the first layer a little bit, the perimeter of it a little bit smaller so that when it squishes, it goes back to where it's supposed to be. That wasn't my problem. Well, now this one did have that problem, but I wasn't worried about that problem. My problem was that nothing fit in the holes. So there is also an XY, whoops, I didn't want to actually select it. There was an XY hole compensation. So it will let you put in a positive or negative number on how much larger to make, or smaller, to make any kind of hole that is in the print. So it doesn't bother the outside, the perimeter, only the inner holes get enlarged or shrunk by, and I put 0.2 millimeters. So when I put the 0.2 millimeters in there, before, you know, this wouldn't fit. I could probably force it, but things would break. But after, it drops right in. So I don't have to redesign the part at all. I just tell it my compensation for XY holes. This is related to what material you're printing, how you designed the part in the first place, did you build in tolerance? So it's related to other things. You can't just always say that you need 0.2 millimeters of XY hole compensation. But once you've printed with the material a while, then you could find a number that would fit in there, or you could design parts to match whatever you needed, the amount of tolerance you needed. This one, the contour compensation, is same idea, except not the holes, it's the outside part. So if your outside geometry was too big or small, you could scale it all without changing any of the hole sizes. So you can use that if maybe you don't have access to the original file and you don't want to go to Mesh Mixer or something and try to resize all the holes. You just have a STL file to work with. That's a way that you can modify it for your printer's tolerance without having to go and edit the file. So that's what I did. All right. So let's see if we can put our heated insert in here. So we're going to have to back out a little bit. Let's see, there it is. Here's our heat set insert. So remember, this guy is a set of brass threads that, yeah, they match this screw M5 or whatever screw. They come in all different sizes, but the idea is there's these little ridges that I can heat this up, put it into a material that is going to soften when it's heated, and set this guy in here, and now I have actual metal threads. So this is when you want to think about, I'm going to have to bolt this together and take it apart several times. This is a good way to do that. If you print the threads, so these threads printed fine after the XY compensation, then some number of times, depending on how much you tighten this down, some number of times this is going to work okay, but it won't hold quite as much force. Actually, these aren't perfect either. Depending on how these are made, they can rip out also. But let's show you how to set this in here. So we need a heat source. We're going to use our cheapy heat source. Our TPU's printing slowly, but fine. So this is what we're using. We're zoomed in too much. There we go. What we're using. Let me get this little stand so that I have a place to set it down without burning everything. Now, I'd mentioned last time you can use just the regular soldering iron tip. The problem with those is trying to get everything straight, and sometimes, well, this one, it sticks out past the end of, and this is a relatively long heat set insert. It sticks out past it, and so what's on the other side of, am I going to burn a hole in the thing with the tip here? So I do happen to have the little brass tools that will replace this tip, and find the one that fits in there. All right, that one. And now it will work a little better. You can't just buy any tools. There are different types of tools. So these kind work with this kind of soldering iron, and they do make the same type of thing that works with this kind of soldering iron that has tips like this. So depending on what soldering iron you have, if you wanted to have tools like this, you'd have to match up the correct tools. They're not perfectly interchangeable. All right, so let's get this guy plugged in. It looks strange now. Okay, so this one does have a ability to change temperature. I've got it set at the lowest. So the lowest, I don't know if you can see, the lowest is 180 Celsius, because I do want to get the heat set hot enough that it can work its way into the plastic. But if I dump so much heat in there that, like if I turn the soldering iron up to 300 or 400 or 500, then it's going to get so much heat in this, it's basically going to melt its way through the thing. So you, in my experience, you want to insert these at as low of temperature as possible. So this is the lowest this goes, is 180 Celsius. And sometimes some of these have a little lip that kind of gets you started. This one does not, so that's a little bit of a pain, but we'll do the best we can. I might want some sort of way to hold this so that it's I can kind of align it. Let me get some tweezers. So now I've got some tweezers that I can kind of hold over here, and this should be heated up. And we're going to do something like this. So you apply some downward force, and once it starts going, so it's going now, you kind of have to monitor. Basically, you just don't want to overdo it, because once it starts, the heat's going to stay in that brass insert for a while. I might would have gone a little bit hotter at the, because this is a larger insert. I'm normally putting in ones that are less than half this thickness. So now that I think about it, probably a little more heat would have been okay on this larger one. In fact, let me back it out and bump up our heat a little bit. One thing that's happening here that you may not can tell, let's see, is that we have only 2 walls, remember, because we were trying to save time. I'm going to go to 200. Printing it, we were saving printing time. And so with only 2 walls, there's not a whole lot holding the top surface. I think I only did 2 top layers also. So it's pretty flimsy there. And if I push too hard, I'm pretty sure the top is just going to collapse on me. So we're at 200. Let's see if we can get a little more. I don't want to push. I don't want to force it in with axial force. I want the heat to do a lot of the work. Because it will collapse the top layers otherwise. Also, doing this by hand, it's really easy to, wiggle this back and forth. That's definitely going to give you problems. This one's being, I actually don't know how accurate, this is a, what, $15? So I actually don't know how accurate the readout on here is. It could be that, it's telling me 215, but it might be way less than that. So it is heating it up and working its way in there, but I don't actually know how accurate this readout is. So maybe not always as low a temperature as you can go. When I use this guy, it's a lot more, lot quicker than what this one's being. And it could also be a function that this insert is quite a bit larger, so there's more metal to heat up in the first place than what I'm normally inserting. Alright, so I'm going to give it quite a bit more temperature here, because just the mass of brass that this one is not responding well to the lower temperature. You can see our upside down TPU printing okay. It looks like I still have some issues with the nozzle being a little too close to the bed, but it's sticking well and it's printing fine. So eventually I will get enough heat into this. I guess I need some way to check that this soldering iron, I haven't used this. This is a new soldering, well, I haven't used it before anyway. It's different from the one I normally use for the heat set. I might have to switch over to the one I normally use because it's sitting right there. There we go. So one thing I can see is that since I don't have enough top layers, you can see what happened here. I also don't remember how deep I made this hole. Alright, turn this guy off. So I ended up at 260 is what temperature I was on. But see how with this particular one, it indented around it. It is set in there. You know, we do have metal threads in here now. And it's still pretty warm, so there's some ability to, you know, straighten things out. But with only 2 walls and 2 top layers, there's just not a lot of plastic for supporting the heat set. But we just did that in an attempt to, you know, save some time. But we have reusable metal threads in here that if I needed to bolt something to this, now I've got, you know, I mean, they're in there pretty tight. I'm sure I could get some kind of tool or machine and rip them out, but for regular amounts of fastening, then they'll be fine. Same thing with these printed threads. Remember, we just used Fusion 360 to actually model threads into the plastic. We did that last time. This one, the one that used the plastic screw, and this one, the problem with this one is I would need to get the nut in the slot here, and it's just not quite the right size, the slot. And this hole, I don't think this hole expands when it counts as a, you know, the XY hole compensation over here. I don't think this one counts as that because it's really kind of an external perimeter. So I think that one didn't expand on me. So I would have to go back to the model and fix that, or take some kind of file and get it a little bit larger in order for the nut to slide in there. The top part works. I don't see the little screw for it. Well, there it is. So this part of it is fine. It's a little bit tight still. It needs a little more clearance there. The nut here, wherever it went, is fine. It's fine. And this one, this is where we were going to put this kind of fastener, or this kind. And this hole is a little bit too small. So I think I did half of the diameter of the major diameter for those screws, and I probably needed to do more like 3/4 of the major diameter, or the root diameter, because it's wanting to, what it's doing is it's actually pulling the top layer away from the infill. It's bulging out, so anytime I put any pressure on it, it's just pulling it apart. Alright, so it looks like our TPU is still going. It's a little bit rough I'll let you see it. I'll switch it right side up. A little bit rough in there, but it is printing okay. Some of the accelerations on this have not been tuned, and you can kind of see the accelerations are a little bit too fast, and it's wanting to skip some steps. I noticed that it did that on a print I printed earlier, that the print was fine except when it wanted to do a travel acceleration, and it would be a little too fast. So I need to go tune down some of the travel accelerations. All right. See, like that kind. We'll let it go. It says it's got another, well, it's 21% done, so still got a while to go on that. Hopefully, we'll have us a little nozzle box that kind of has a sort of snap-on lid. And we'll come back on not Wednesday, so it'll be Friday, and see how this goes and talk about some new stuff. All right. So I'll see y'all not Wednesday, but Friday.